Hello everyone. Today is the lecture number 8 for engineering economy. And before we continue to learn the important techniques for cost estimating, we are going to review the homework number 1 first, okay, as we planned. And so in the homework number 1, we have two sets of questions. One is about the concept of different types of costs. We have this, drop-down list selection problems for you to choose which definition is regarding which type of cost. And after that, we have a set of questions regarding the formulas we have learned to calculate profit, revenue, demands, and so on. Okay. All right. So the first question is, okay, for the given descriptions, can you tell what type of cost it is? Okay. So the first one. What term is used to describe costs that have occurred in the past? That's the keyword, in the past, and have no relevance to estimates of future costs. No relevance for future costs. So something happened in the past you couldn't change, and you should not include that factor in your current decision making. Well, that's called sunk cost, right? And the second, what term is used to describe costs that are incurred because of the use of limited resources? Okay, you got limited resources like time and money, such that the ability to use those resources to monetary advantage in another way is foregone, which means if you invest your money and time in option 1, then the possible profit you can earn in selecting option 2 will be gone, right? So that's the opportunity cost. Third, what term is used to describe costs that are unaffected by changes? Unaffected by changes in what? In the activity level over a feasible range of operations for the capacity available. Okay, so it doesn't change along with how many products you are producing. So that's gonna be fixed cost. Fourth, what term is used to describe costs that in total changes in relation to the quantity of output or other measures of activity level? Okay, so the more you produce, the more you use. That's kind of like a material cost, right? So it's what? Compared to the fixed cost, that's variable cost. Five, what term is used to describe costs that refer to the additional cost? The additional cost that will result from increasing the output of a system by one more unit. Okay, so you want to produce one more unit. What is the additional cost? That's the marginal cost. On the one more thing I want to let you know is on our textbook, the marginal cost is also called incremental cost. Well, in some cases, these two terms are used interchangeably. Okay, but there are some rare cases. There are tiny differences between these two concepts, but the marginal cost is very common in the world of economy. That's why I use the marginal cost here, because when you go out and you talk to other people in the economy field, usually they use marginal cost for the additional cost for that one more unit. Okay, that's it's just the your language, the habit. And okay, so let's continue. Number 6, what term is used to describe costs that are repetitive and occur when goods and services are produced on a continuing basis? So if you still want to continue the business, you need to repeat some payments, and those payments are called recurring cost. Did I spell it correctly? And number 7, what term is used to describe costs that can be reasonably measured? So it's quantifiable and allocated to a specific output of work or activity. Okay, so you can measure it and you can allocate how much cost for what product. So that's what we call direct cost. And 8, what term is used to describe costs that are not repetitive? Not repetitive, that's something opposite to the repetitive cost, right? So it's non-recurring cost. Okay, so these are the answers for those definitions. I hope you all get this right. Okay, because this is just basic terminology, no calculation involved. All right, so the next sets of questions are all based on this one statement. Okay, so a company has established that the relationship between the sales price for one of its products and the quantity sold per month. So the relationship between P and quantity sold per month, that's going to be D, right? So the relationship has been determined already, which is this. Okay, that's an equation, and also it tells you D is the demand or quantity sold per month, and the P is the price in dollars. So the fixed cost CF is 1,000 per month, and the variable cost is 30 per unit. Because it's per unit, so it's gonna be C lowercase v, right? And all the other questions are based on this problem. So if we write the relationship between P and D in a formula like P is A minus BD, right? That's a generic formula or equation we have introduced in the class. Then what are the value of the constant A and B? So if you put a specific value for A or B, that will give you a specific relationship, right? So for different types of business, different types of products, the A and B could be different, but the form of this formula or equation is gonna be the same. Okay, so the first question is asking you, for this specific company and the product, for this given relationship, what is the A and B, and what is the CF and the CV? Okay, and I said the CV is the C lowercase v, because it's hard to type that type of V in this, in this Canvas system. So I have to explain that. I hope you all get that, okay? This is not a C capital V, this is a C lowercase v. Okay. All right, so to find the A and B, it's very easy. You just write that given relationship like this, align well with this general formula, and then you just compare. Okay, so A is 75, B is 0.1. Okay, There is no negative sign for B. I said that many times, so don't include that negative symbol. So A should be 75, B should be 0.1. How about CF? CF is given as 1000. You don't have to include this symbol, the dollar symbol, okay? And CV is lowercase v, okay, is given as 30. So that is your answer. And you just go back and see what is the same one, okay? So A 75, B 0.1, CF, CV. Seems like the first option is the right one. So question number 2, to find the maximum profit per month. Maximum profit, okay, that's the profit, okay? Keep that in mind. It's profit, not revenue. You'll first need to find the demand associated to the maximum profit, right? This demand, so the demand where you can reach your maximum profit is called the optimal demand, and we write it as D star, okay? So this is the right answer. Question 3, select the right formula for optimal demand. So optimal demand is D star, right? Which can make you reach your maximum profit. So this is your formula to calculate D star. Question number 4, what is the correct value of the optimal demand? All right, you have already selected the right function, right? So D star is A minus CV over 2B. From here, you already know what is A, what is B, what is CV. So the calculation is very easy. Okay, you just copy that formula. So D star equals to A minus C lowercase v over 2B, right? That's the formula or equation. And then you substitute A, C, V, and B with those values. A is 75, CV is 30, 2 times B is 0.1. So 75 minus 30 is 45. 2 times 0.1 is 0.2, and the answer is 225, okay? So the first one is correct. Select the right formula to calculate profit. Okay, so what is the formula to calculate profit? So we have learned that it's this one, okay? And to calculate the maximum profit, we're already at number 6, the question number 6, okay? To calculate the maximum profit, you are going to use this equation, but you should replace the D with the D star, so that you are calculating the maximum profit, okay? What is the value of the maximum profit? Well, you already know the value of B, the value of D, right? Because you are going to use the D star, right? And the value of A, C, lowercase v, value of CF. So you just need to replace these letters with their values. All right, so let's do it here. So max profit equals to minus B, the value of B is 0.1, right? Times D, we said we replace D with D star, and D star is what? D star is 225. So 225 to the power of 2 plus A is 75 minus C lowercase v is 30. times D again, and we replace D with D star, so that's 225 minus CF is 1000. Okay, so how do you get this from this equation? Okay, and now it's just the time to calculate. So 0.1 minus 0.1 times 225 to the power of 2 is 50625. 75 minus 30 is 45 times 225 minus 1000. So the final answer is $4062.5 US dollars. And obviously this is the correct answer. Okay, question number 8. To determine the range of the profitable demand, which formula to use? So the range of profitable demand means between these two demands, you are making profit. Out of that range, you are losing money. Okay, so it's very easy. That's gonna be this one. This one is very long, so when you do the calculation, you're gonna be pay attention to the calculation itself. Okay, when do you open that parenthesis? When do you do the square or do the square root? So first thing is you need to just replace the variables in this formula by the values. Okay, so we have D prime equals to, okay, minus parenthesis, A is 75, CV is 30, okay, plus minus, we have this bracket, okay, so we have another 75 minus 30 to the power of 2 minus 4 times negative 0.1 times negative 1000, and the whole thing you need to do the square root, and then you divide this long term by 2 times negative 0.1. Okay, this step is just to replacing all the letters in this function, in this equation, with the values. Okay, with the values given. And then you are gonna do the calculation within the parentheses first. Okay, so first you're gonna do 75 minus 30, that's gonna be 45, right? And this is 45 2, but you don't forget about the square, the power of 2. Okay, and this 2, negative times negative is positive, 0.1 times 1000 is 100. Okay, and this 2, the product is negative 0.2. Okay, now the next step is just to rewrite this with the green numbers. So it's negative 45 plus minus 45 to the power of 2 minus 4 times 100, and the whole thing to the power of half, which means it's a square root, over negative 0.2. Okay. And then next, what you are going to calculate is the part in this bracket. Okay. So 45 to the power of 2 is 2025. And 4 times 100 is 400. Okay. So 2025 minus 400 is the number under the square root symbol. Okay, so 2025 minus 400 is gonna be 1625. Alrighty here, 1625. So that's the number in this green bracket. Okay, so now the next step is to replace the whole term in the bracket with that final results. And then to the power of a half, which means it's a square root. So you can write the square root at this point. Make sense? And then still you have to divide that by negative 0.2. Okay, so I hope you can follow this step-by-step calculation. You wanna, make sure the orders of the calculation are correct. Okay. All right. Then what's next is you're going to calculate what is this. Okay. So square root 1625 is 40.31. Okay, then your calculation is gonna be negative 45 plus minus 40.31 over negative 0.2. Okay, here you can divide this to two equations. One equation is for D1 prime and the other is for D2 prime. Okay, so D1 prime is the lower bound of this range, of this profitable range. Okay, so you're gonna use negative 45 plus 40.31 over negative 0.2, and the answer of this is 23.45. Another upper bound of this range is gonna be negative 45 minus 40.31 over negative 0.2. That will give you a higher value, which is positive 425.56. Okay, so between D1 prime and D2 prime, that's your profitable range. If you want to write this range, you can write it as 23.45, comma 425.56 parentheses. That's the profitable range. Okay. So now we can answer the question number 9. What is the lower bound of the profitable range? So this is the lower bound. So 23.45 is the answer. And question number 10, what is the upper bound of the profitable range? That's going to be 425.65. So this is your answer. Next question, we have learned that total revenue, now we're talking about total revenue, okay? It's different from total profit. Given the conditions, what is the maximum total revenue the company can get? Okay, we have learned the max total revenue. We can write it as TR, right? Total revenue. The equation is a to the power of 2 over 4b, right? That's what we have learned in the class. So now, given a and b, you know the values, right? You just replace the a and b by the values. So a is 75 to the power of 2, 4 times b is 0.1. So 75 the answer is 14062.5. Okay, so obviously this is your correct answer. And it's a dollar sign here because that's the revenue. And question number 13, at what demand the company will reach this maximum revenue? We said the demand related to the maximum revenue is the D hat, not D star, okay? And D hat, we have a equation, which is A over 2B. So A is 75, 2 times B is 0.1, so it's gonna be 375. So this is your correct answer. Okay, so this is all about the homework number 1, and I want you to practice this if you got something wrong with that. And this is a very important example. You're gonna see that in the test and in the final exam, okay? But we will have the numbers changed, of course. What stays the same is the questions and the calculation formulas. So you have to practice a lot to get the right answer, especially about the profitable range. I know it's a long equation to use, so you have to calculate step by step, okay? All right, the next part is to continue to learn those important techniques for cost estimating. In the last class, we have learned several. We have learned like index method, right? We introduced more details about like how to find the price index and how to use that to estimate something's price or cost for another year. And then we have learned the unit method. That is very useful, but it's very simple, right? It's because we talk about this unit method almost all the time. Like when you want to build a road, you can estimate like how much cost for 1 mile, and then you just multiply that unit cost by how many miles you're building. That's very easy to understand. And then an extension of unit method is called factor method. The factor method is sometimes in the complicated project, you have some part you already have the direct estimate as a lump sum, okay? But for the other parts, you still have to use the unit method to calculate, okay? How many units and the cost per unit, and then you sum those pieces together. So that's what we have learned in the last class. And today we're going to learn a new technique called power sizing model. So power sizing model, it recognizes that the cost of something varies as some level of changes in capacity or size of the project. One example is, imagine that you are building a road, okay? You're paving a road actually, and then you have some experience paving like 1-lane road, okay? For example, like this one, this pavement, it's just 1 lane. Everybody knows that, Okay, this is just the intersection in front of our stadium. Okay, and so that branch of the road is one lane. So imagine that if you have paved this one lane part, and then now I want you to estimate what's the cost for paving this surface, which is 2 lane. Okay, so a very simple estimation is gonna be, well, you double the 1 lane cost, right? Because 2 lanes means the size is bigger, twice bigger than the size of the 1 lane pavement. So you might want to double the cost. And so that's how the power sizing model work. So it tells you that there is relationship between the cost and the size. So the bigger the size, the higher the cost, right? But sometimes you might find there is the economy of scale included. Like to pave the 1 lane road, you have to rent some construction machines, paver, and workers. You deliver the material to the site, right? That's what you need to do. And then if you pave the 2 lane roads, you still have to do all the same thing. Maybe the same number of pavers, the same number of construction machines, same number of workers. You just need longer time, you just need more material, right? So the cost for you to transport those machines and people to the site stays the same, okay? Which will keep the cost for 2 lane pavement maybe much lower than the double of 1 lane pavement. You know what I mean? Because some part of the 2 lane pavement stays the same as the 1 lane pavement. That's why you have the economy of the scale. Okay, so sometimes the more you construct, the total cost or average cost will go down. Okay, and so that's a phenomenon involved in this power sizing model. All right, so let's go back to this equation. So the model says that, okay, we consider the size and we think the size make differences in the cost, okay? So there is a equation between describing the relationship between the cost, C, and the size, S, okay? So C is the cost, and CA, CB, which means we have 2 scenarios to compare. One scenario is known. CB is something, the cost of B is known. And CA is cost for plant A. CB is the cost for plant B. Or we can say project A, project B, okay? And usually, if you write the formula like this, which means CA is unknown and CB is given. Okay, and also another thing is you have to compare these 2 costs at the same time. So if you have the given cost for project B at present, then the estimated cost for project A is also at present, right? We all know that the price and the costs and money change with time, right? So you have to make sure that the comparison is done at the same time. And okay, so on the other side of this equation is the size A, size B. So SA is size of plant A, SB is size of plant B. Okay, so you are given that there are 2 sides of the similar plant. One is bigger, one is smaller. One is more powerful, one is less powerful. And they're all given. And another variable in this function or in this equation is X. So X is called cost capacity factor to reflect the economies of scale. Remember I said that? So sometimes you have economies of scale, like the more you build, Actually, the average cost is getting down, but it's not always the case. Sometimes it can be, these economies of scale. It happens when your company gets super big. Like, just imagine that if you have a bigger international corporation to produce, clothes, then if the designer wants to put up a new design, maybe change the color, change the material, then it will go through a long chain of decision making. Okay, so the material department needs to know that, the design department needs to know that, and the marketing department needs to know that, and everybody needs to be on the same page and approve that idea. So it's gonna be like a long time and a bigger cost to make this little change. That's these economies of scale. Okay, but if you just have a small company, maybe just 10 people, okay, one person is to design, one person is to buy the material, one person is to do the advertisement, then for your small company, if you want to change the material of a t-shirt, right? It's very quick. You just sit on the table and then discuss maybe 5 minutes, and then everybody think it's a good idea, then let's go, right? So usually in a bigger company, your economy of scale is hard to get. The more you produce, the more design you get, the much more marginal cost you're gonna pay. So average cost will go higher. Okay, but here in this equation, what can the x is something can tell you if it's a relationship for economy of scale or diseconomy of scale, and you just need to see if x is bigger than 1 or smaller than 1. If x is smaller than 1, which means the marginal cost will decrease, okay? And you have the economies of scale. So you want to build bigger plants. You want to pave wider roads. And if x is bigger than 1, which means the more you produce, the higher the higher marginal cost you're gonna have, then you're gonna experience these economies of scale, and that's not what you want. Maybe build a larger plant or producing more is not a good idea. Okay, but you don't have to worry about that. It's just something additional I want you to learn from this. Okay, now let's take a look at this example. So suppose that an aircraft manufacturer desires to make a preliminary estimate of the cost of building. They want to build something, okay? They want to build a 600 MW fossil fuel plant for the assembly of its new long-distance aircraft. So they are building a new project or a site, okay, or a plant. And the size of it, sometimes we use the area as a size, or we can use the number of units as a size. And here we can use the capacity value as a size. So 600 MW is the size of this new plant, okay? And it is known that a 200 MW plant cost 100 million 20 years ago. Wow, this is tricky. Okay, so many information in this sentence. It is known that a 200 MW plant, that's another plant with a lower capacity or lower level of power. Okay? And the size is 200 compared to the new plant whose size is 600, okay? And the cost of this smaller plant is 100 million, but the price is 20 years ago, okay? Keep in mind the time stamp is 20 years ago. So, let's just write down the given condition here, okay? So seems like we know the price of the smaller plant, like what we said, okay, CA over CB, we just wanna, copy this formula first. And actually the formula, we have two forms, and then I would like to use the second form a lot, because that will give you the unknown variable CA on the left side and moves everything to the right side. Okay, so CA, let's write it here actually. CA, that's the unknown cost. Remember that is CB times size what? Size A over size B to the power of X. That's your equation. Okay, and we said that the CA is the unknown cost, so CA must be the cost of this 600